Okay, the problem is a 0.144 kilogram baseball is pitched horizontally to the right at 38 meters per second. After it is hit by the bat, it moves at the same speed but in the opposite direction. What was the change in momentum of the ball? What was the impulse on the ball? And if the bat and ball were in contact for 0.0008 seconds, what was the average force the bat exerted on the ball? Okay, so given. Okay, so the ball was moving to the right at 38 meters per second. So here's the baseball, and I'll just show it like this. And so it's got a velocity of 38 meters per second. Okay, and then after it's hit, it's moving with the same speed, but in the opposite direction now. And the key to this is recognizing that if it's moving in the opposite direction, this is the initial velocity. Well, the final velocity then is negative 38 meters per second. And it's in contact with the bat for a time of 0.0008 seconds. That's 0.8 milliseconds. I think in the book it was 0.8 milliseconds. And what are we trying to find? Well, for A, we want to know what is the change in momentum of the ball. Oh, I forgot to put the mass. The mass is 0.144 kilograms. We want to find A, the change in momentum. B, the impulse. And, B. And then part C, what was the average force on the ball? I'll just call it F. From the bat onto the ball. Well, let's solve it. Well, and by the way, in the actual book problem, right, it wanted you to draw a picture of before and after picture. I just do that in what's given. I always draw the problem if I can. I read it and then I draw a picture of it, and it helps me visualize what's going on and helps me actually do the physics. So, well, for part A, the change in momentum, well, that's equal to a mass times a change in velocity. And a change in velocity is the final velocity minus the initial velocity. Well, I know all these things, they're all given. So the change in momentum is equal to 0.144 kilograms. The final velocity is negative 38 meters per second minus 38 meters per second. So I get my calculator out, and let's see, negative 38 minus 38, that's negative 76. So it's 0.144 times negative 76, and you get a change in momentum. It's negative 10.9, and it's 444. I'll just round it off to 10.9 kilogram meters per second. So that's the answer to A. I'll tell you how to grade this for points here in a minute. Then for part B, now part B is kind of a trick question. Impulse. Is there a mistake here? Do you guys agree with this answer? Okay. Impulse is equal to a change in momentum. That's the impulse momentum theorem. So the impulse is just negative 10.9. Now, impulse, right, is force times time. Oh, I'm off. No, I'm okay. Impulse, if you think of impulse as being F times delta t, that's a force times the time. So even though this has units of kilogram meters per second, I'm going to change it to Newton seconds. Now, you didn't have to do that. I'm not going to take points off if you didn't. But that's a way of thinking about an impulse. It's a force times time. And when you think about a change in momentum, well, that's a mass times a velocity. So I just changed the units onto that. So there's, so it's negative 10.9 Newton seconds. That's my answer for part B. Then for part C, well, it wants to know what is this average force. And we call it an average force because we're just treating, in reality, when the bat hits the ball, when it first contacts the ball, the force is 0, but then it rapidly increases to some maximum amount, and then as the ball rebounds off the bat, the force decreases with time. But that's a little bit complicated, so we're just going to assume, hey, what's the average force on the ball? And so what you do is you just divide the impulse by the time, and you get the average force. So the force is equal to negative 10.9 Newton seconds divided by this delta t, and this delta t was given to be 0.0008 seconds. And so the average force is negative. So just take my answer from before, and I get negative 1, or negative 13,680. You could call it 700, 13,700 to round it off. If you put negative 13,680, I'll accept it. Now the seconds cancel, and I'm left with newtons. So there's my answer for part C. So let's take a look at the whole thing. See if I can erase this up. Okay, so there's the whole thing, the problem. Really a big part of all of these physics problems is doing a good job with given, find, and solve of setting up the problem and really writing down what's given and putting the correct sign with the velocities, noticing that these velocities are in opposite directions. So when you figure out that change in velocity, these actually add up to negative 76 meters per second. Okay, any questions? Yes? Oh, right here? I was going to put a box around it, and then I decided to put it underneath it. Anything else? Yes?
In the first part for A, if you distributed out the N to the VF and with the initial, then the negative 38 meters per second would cancel out with the minus the initial, and it would be positive.
Let me go ahead and stop this.